So this is for Algebra 2, section 11.3.3. Real quick, before we go over the actual questions, I want to look at this unit circle. So there's some explanation of the unit circle that you can we'll look at in a second. But basically, it gives you like the complete unit circle starting at 0 degrees. Starting at 0 degrees and working counterclockwise all the way, like creating a full circle. So it goes by 15, like it goes 30, and then 15 degrees would be 45, 15 from there would be 60, then add 30 to 90. Then you go to 120, 135, 150, going all the way around the circle. So it starts at 0 and a full circle is 360 degrees. So I'm actually going to add that 360 degrees right here. So if you go around the full circle, that would be 360 degrees, okay? And then you can see in red, all of these red angles are also angles, but they're radian measures. So they're listed in pi, in terms of pi. If I go all the way around a circle in terms of pi, I will end back up at 2 pi, okay? So in radian measures, a full circle would be 2 pi. And then you also have, around the outside, you have these points, which are the ordered pairs. So you can kind of see those ordered pairs, which we're going to refer to in a second, okay? Okay, so every ordered pair on your unit circle, and I'm going to include this down here so that you have it for your notes. Every ordered pair, xy, represents the cosine of theta and the sine of theta. So if we look at one of those points, because a lot of these questions involve those points. So if we look at one of those points, let's zoom in here and we look at 30 degrees, okay? So 30 degrees is right here on my unit circle. If I look at the point associated with 30 degrees, it's the x value is radical 3 over 2 and the y value is 1/2, okay? So what I'm saying is that this x value right here is the cosine of 30 degrees, since that's the angle we're looking at. This y value is the sine of 30 degrees, okay? I could pick any point on my unit circle. So I could say, let's look at this right here. And I could say, okay, what's the cosine and the sine of pi? Or I could say, what's the cosine and the sine of 180 degrees? Well, again, the cosine is my x value. So this is the cosine of pi. And the sine is my y value. So the sine of 180 degrees, or the sine of pi. Okay, so we can use either of those. So that's just a little bit about like how we're going to use parts of the unit circle. And there's one more thing I want to add on here that I think is worth saying. If you're looking for the tangent of an angle, so a tangent of theta, tangent is defined as the sine divided by the cosine. So the sine value divided by the cosine. Okay, so then if we think about that, the sine we just said is our y value. So really, if the sine is our y value, then we could say that's y. The cosine on the bottom is our x value. So this is really just represented as y over x. And we're going to use that a couple of times here. So the tangent of theta is whatever the y value is of your point divided by the x value of your point, okay? Okay, so we're going to refer back to that. I took that picture straight from Apex. So I think it was like the 11.3 study, 11.3.1. All right, so this first question, it says, which equation shows that the Pythagorean identity is true for theta equals 2 pi? Select the equation that is in the form, and then they want you to find the equation that's basically the correct version of this, okay? Okay, so I'm going to go ahead and write in orange since I just highlighted there. I want to look for the point 2 pi, or the point, I guess the ordered pair at 2 pi. So on my unit circle, we said we start at 0, and if we go around the full circle, we get back to 2 pi. And if we scroll down, this is the point 1, 0, okay? So right here, I'm looking at this point, this ordered pair 1, 0 on my unit circle. Okay? So, again, we just said that the x value represents the cosine, the y value represents the sine. So what I'm going to do, I'm going to just plug in those values into this equation. So now this is kind of written weird. When it says sine squared 2 pi like that, it really just means like the sine of 2 pi, that whole thing squared. So we just found the sine of 2 pi is right here, it's 0. So I'm going to replace this, the sine of 2 pi is 0 and squared, plus the cosine of 2 pi we just found was the x value. So the cosine of 2 pi right here is our x value, that's going to be 1. So I'm going to plug in 1 here, 1 squared equals 1. So this question just asks me to like show that the Pythagorean identity is true for this point. So right here, 0 squared plus 1 squared equals 1. If I actually solve that, it'd be 0 plus 1 equals 1, or 1 equals 1, and then you can kind of show it. But we're just looking to go this far to show the identity, okay? Okay, if the terminal point of theta is 0, negative 1, what is the tangent of theta? So again, we kind of went over at the bottom to find the tangent of theta. Tangent is equal to sine divided by cosine. Well, again, we know the y value is the sine, the x value is the cosine. So to find the tangent, I'm just going to do the y value divided by the x value, okay? So negative 1, right here is our y value, divided by the x value is 0. And then this is a problem. I am not allowed to divide by 0. You can't divide by 0 because if you're taking negative 1 out of nothing, there's nothing there to take it out of. So we say it's undefined, okay? All right, question 6. On a unit circle, the terminal point of theta is 1/2 square root of 3 over 2, or radical 3 over 2. What is theta? So because you don't really have to memorize the unit circle, I would just go to the unit circle and figure out in terms of radians, all of those are in the pi, figure out where is this point. Okay, so we're going to look for the x value of 1/2 and the y value is radical 3 over 2. Okay, so let's go down here. I can just quickly find it because I kind of know where it is. That's going to be pi over 3. The x value is 1/2, the y value is radical 3 over 2. So pi over 3. There you go. Sorry. Okay. The next one says, in a unit circle, theta equals pi radians. What is the terminal point? Okay, so I kind of know from my unit circle, again, I start at 0, and if I go around pi, that's half a circle. So I want to know what is this point right here. That's going to be the point negative 1, 0. And again, you can just refer to your unit circle. Everything you need is right here on this circle. So we wanted to look for pi. What is the terminal point? That's this point right here, negative 1, 0. Okay? So negative 1, 0. All right, and then the last one, the domain input values of the cosine function is, so this is a little bit different. It says, the domain or the input values of the cosine function. So if you look at your options, it says angle measures between 0 and pi. That means you cannot have negative cosine values, which we do have negative cosine values if you just think of like, oh, I'm sorry, this is the cosine function. Okay, this is a little bit different. So the cosine function is, if you graph the cosine, and we're just going to look at one period of the cosine. So we start at 0. Well, it doesn't start at 0 technically, but we're starting at our x value of 0. And then we're going to count by radian measures. So pi over 2, pi. This next one would be 3 pi over 2. And this next one would be 2 pi. Our y values are just positive and negative 1. So what happens is it starts at a positive 1. It goes to 0. It goes down to negative 1, comes back to 0, comes back to positive 1. Makes this U-shaped graph, okay? That would be one period of the function, but it continues forever. We just can continue this graph and it's going to continue doing this in both directions. So what happens is no matter what x's technically we plug in, and when I say x's I mean like whatever angle values right here, positive or negative, no matter what our angle measures are, we can plug them in and get a value for cosine, okay? So all positive and negative angle measures. And again, that's outlined and explained in your Apex video.